Okay, Algebra 2 students, here's the first video for section 2.7, linear quadratic systems. How can you solve a system of two equations or inequalities in which one is linear and one is quadratic? In the end, you'll be able to solve linear quadratic systems. First example, determine the number of solutions. How many solutions can there be for a linear quadratic system? So picture a parabola and a line, and how many times would they intersect? To solve this, we have a very basic very basic equations: y equals x squared and y equals 2x. How many real solutions does that have? We can graph them. The graph seems to show that the quadratic function and the linear function intersect at 2 points. Looks like they cross here at 2, 4 and here at 0, 0. System has two real solutions. That's all they wanted to show there. All right, so they graphed them and saw where they crossed. How many solutions can there be for a linear? Same question. How does modifying the linear function in the system affect the number of solutions? So we still have y equals x squared, and we still have y equals 2x, but now we're going to add b to it. How does that affect the number of solutions? Well, let's take a look. They have, let's see what they have right now. They have, there's a lot of overlap here. They have the value of b is 2, so they have it intersecting at 2 instead of at 0. Okay, when b is greater than -1, there are two. Well, let me just play around with it. Zoom out first of all, so you can see that there were 2 points that it crossed at. But if I change the value of b, if I drop it down here, it still has 2 intersection points. Here, there's still 2 intersection points. It's saying as long as we're above -1, we're going to have 2 intersection points. If I go down to -1, it crosses only in one place. Anything below here, and there's no intersection points. That's this right here. When b is less than -1, there were no solutions. If I went above -1, there were 2 solutions. You might say, there's not 2 solutions here up at 0, 8, but if I zoom out, you'll see it does cross again up here. In fact, if I went all the way up to 20, if it lets me, and it's not, I think it has it's required to stop at 10. But that's how we're just going to graph it and see how many intersection points it has again. That's all we're learning, I guess, in this section. We'll probably have to do more work in a later example. So determine the number of real solutions in this system. Now this is different. It has 3x squared instead of just x squared. But go ahead and graph those and see where they intersect. And I'm going to use my graphing calculator because I'm more familiar with that than with Desmos. And I already had it ready. I don't have Desmos ready. 3x squared and 3x minus 2. Zoom standard. Am I going to be able to see the answers? Oh, I'm gonna zoom in a little bit here. Zoom. I'm going to use zoom in, and I want to zoom in right about, where's my cursor? Right about where I want to zoom in. Let's zoom in. I don't think they cross. Yeah, they're not intersecting, so I'm going to say 0. 0. There are no real solutions. Okay, hopefully that was enough examples for you to know how to do these problems. 11, 12, 27, 28, 8, 9, 10, 13, 14, 15. That's it for this video. Have a great day.